So what was the GLEC grant? The GLEC grant, Pass received a grant from Alberta Eco Trust to develop some solutions to the overlapping crises of housing, climate change, and skilled trades lack thereof. And these integrated design process meetings are where we're kind of asking the industry for help us to come up with solutions. So some of the final goals is that we come up with a missing middle plans that are affordable to build and to own. They're low embodied in operational carbon. They're durable, resilient, energy efficient, and all electric. We'll put that in maybe. We're going to discuss that question later today. Specifically to today's goal, the goal of today's meeting is that we can end up with a bit of a report that kind of documents the discussions and lists a number of cost-effective, high-performance mechanical systems for missing middle-sized projects. And then we can send that out and help accelerate their adoption. Because there's a lot of new stuff coming out, and everyone taking the time to learn all the different equipment is kind of time-consuming. So this was not step one. The first step of the grant is we sent out a survey to the industry, and we got 62 responses, fairly good representation from kind of the architects, designers, government, builders, and developers, and then kind of a smattering of other stakeholders, just so we do have a fairly round or full representation of all the stakeholders in housing. Then we also asked them, and it was good to see that most of them had been involved in the missing middle projects before, so they were talking from experience. The other big thing that we learned is over 93% of them wanted us, the grant, to create fewer, more detailed, and ideally pre-approved or fast-tracked designs. So that's why we didn't just jump straight into making a whole bunch of designs, is because we've been told that they want fewer, more detailed ones. So this is how we're kind of, again, getting more detailed on what those designs should look like. We asked what size ADUs and these smaller units should be. We unfortunately didn't get great correlation. There's lots of different numbers all over the range. We did take an average, and roughly the developers and affordable housing providers wanted smaller units, and the renters wanted bigger units, which isn't overly surprising. We did also ask about how many bathrooms these missing middle units should have, just because, as probably most of you know, bathrooms are pretty expensive. A full bathroom can cost anywhere between $37,000 and $74,000 by the time you put all the equipment in the space. So if we can just get down by like a half bath by using maybe a Jack and Jill design or some smart designs or some toilets with maybe sinks behind them and get a 1.5 bath to feel like a 2 bath, then that's how we can really drive down improve some affordability, drive down some cost. It was nice to see that the priorities kind of aligned with what we would have put. So construction costs still rule, but it's nice to see that energy efficiency and durable and low maintenance are still kind of those equal priorities. Lower numbers are better. And then some of the other priorities go in ascending order from there. So that was from the survey. Now let's kind of specifies it to what we're talking about today. So let's look at how we're going to heat, cool, ventilate, humidify, and make hot water for 2 missing middle archetypes. These are the plans that we sent out to you. So first is a fourplex. So this is a building that is under construction now. It has been permitted. It's being built by one of the kind of premier high performance net zero builders in Calgary. It's a fourplex. It fits on a 50-foot wide lot. It's a full 2 stories with a basement. The upper level is the self-contained secondary suite is actually on the upper level, and then the main floor and basement is the bigger, larger unit. So they just basically flip the secondary suite to the upper floors to give them better light and visibility. They have interior stairways, and main floor is a fully developed basement. Then the double garage suite was just a theoretical one that we're coming up and we might continue to develop. And it was basically 2 back-to-back ADUs that would fit on a 50-foot lot. So these 2 ADUs could be combined with any other fourplex, duplex, or a single family home. Had a very compact plumbing layout, exterior stairwells to reduce cost and size, and then 4-car garage below. So these are the renderings from that fourplex. And in a previous integrated design process meeting with kind of a general public, we asked them kind of about the look of this one versus your more conventional kind of fourplex with 4 doors at the front. And kind of overwhelmingly, people like the look of this, mainly because it looks like a house. It doesn't look like a fourplex. And the reason for that, if you took a look detailed on the layout, is because 3 of the doors are actually on the side of the house. There's just 1 door at the front. So it looks very house-like. It fits in to the neighborhood better than some of the other designs. This is the main floor. This is the upper floor secondary suites, so 2-bedroom roughly, and this is the basement. So we had 4 elements: integrated design, do a HOT 2000 energy EnerGuide audit on it, as well as a F280 design, and that's where the loads that were sent out to everyone. And the 130 or 134 gigajoules, that was just basically the code compliance number they put in. Again, this is being built to the net zero compliance standard, so there's lots more solar panels on it, and they picked various different options. So we also had 4 elements do what we call an optimization report, where they look at various different types of heating, ventilating, and cooling systems and see what the impacts of on the total energy are. So starting at the top, that's our base building code minimum. That's just your 96% efficient furnace. Then we go to electric furnace. Then we go to a low level heat pump. Then we go to cold climate heat pump. Then option 4 is what we call is our combination unit. So it's a combination boiler that does space heating and domestic hot water, and it's dual fuel combined with a air source heat pump to get some cooling. And then the final one is a ground source heat pump. That is a all electric option. So it has a D superheater to provide the domestic hot water. So again, the COPs will vary. We randomly pick some equipment. We'll be hearing about other equipment today that might fall in this range. But basically what you can see is space heating is still a big part. 56 gigajoules or 28% of the total energy of the building is the variance between the best and worst space heating option. Next, we look at domestic hot water efficiency. So again, starting at just your condensing gas tank going to, or sorry, your non-condensing vented tank going to a condensing tank, and then your all-electric tank, your hybrid hot water tank that lives inside the building, and then your, basically this is a sand and CO2 split system where domestic hot water is, heat pump is outside the building. And you can see that again, the variance is about 15 or 8%. So domestic hot water is still important. This is for the fourplex, so there is 8 people living here. So again, picking a high efficiency domestic hot water is kind of needed to help drive down those energy demands. Next, we'd look at ventilation. So basically, we just had them run scenarios between a 60% efficient ERV and a 90% roughly efficient ERV. And the interesting thing is the variance was not that much. It's only 4.2 gigajoules, which is still 1.2 megawatts, but it's only 2% of the total energy. And this is different than what we're used to seeing in Passive House, where ventilation is much more important. So we dug in a bit deeper, and we found out that the reason that it's, one of the reasons why it's low is that HOT 2000 software defaults to the ventilation system only running 8 hours a day. So depending how you're going to design your building, it could be 2 or 3 times higher variance between the lowest and highest efficiency if we're running it 24 hours a day. So just things to think about, and we'll obviously be discussing this later in the meeting. And again, we're not specifically discussing it today, but I wanted to show that airtightness is still the low-hanging fruit whenever we go high performance, going from code minimum 2.5 air changes per hour down to 0.5 air changes per hour. Obviously, there is some detailing and some cost to go that, but it gives us a 14% energy improvement or 27 gigajoules. So airtightness is still that low-hanging fruit. This is the design for the double garage now. So again, we had 4 elements do the HOT 2000, the F280 design, and it came up with roughly half a ton or 5,200 BTUs or about 1,500 watts of peak heating and cooling load. We made this all electric, so we put in just your basic electric resistance tank. And then the interesting thing that came out of this, because the space is so small, it is high performance, roughly R40 walls, R40 floor, and R60 roof, that the actual energy use from F280 and HOT 2000 for the space heating is that 258 kilowatt hours, which if we times that by 20 cents per kilowatt hour is only $51 a year. So it only costs $51 to heat this unit for the whole year. Ventilation is similar, but again, it could be triple that depending on how long your ventilation is running. Domestic hot water is a much larger number. And then if you add up all of basically space heating, cooling, and ventilation, domestic hot water, it's about 450 or 4,500 kilowatt hours at 20 cents a kilowatt hour. It's still less than $1,000 total utilities for the year. So when we're looking at some of the equipment for this double garage suite, the utility costs or operating costs are going to be low. This is at 100% efficiency. So the upfront costs of the equipment, I think, are more impactful than, say, on the fourplex, where the utility bills are going to be higher. Okay, so that was a very quick presentation to kind of bring us all up to kind of some speed or a little bit of the kind of the back story. So now let's hear from some of those suppliers that are in the room on what equipment they would suggest for these 2 archetypes.
So I'm going to take over for a little bit here. So number one, I apologize. At the beginning, people were having difficulty putting a chat in for everybody. So I think that's fixed. Thank you very much for introducing yourselves. Right now, I have 3 presenters. If there's more, please let me know just in the chat, and we'll go with that. I think we'll start with Christina, if that's all right, Christina. And if you've got something to present, Frank is going to help you walk you through that.
Is that working? Or share? Can you guys see my screen? No?
Yep.
Okay. And you can't hear me either?
We can hear you.
Oh, you can hear me. Okay. Okay, let me try this again.
Okay, just in case it's the problem, maybe make all the people, the presenters, a co-host as well.
Okay, that might be it, hey?
Yeah.
Okay.
There we go. You can see it now.
Is that working now?
Okay.
Yep.
I didn't
Perfect.
do a thing.
Okay.
Awesome.
Okay. Well, nice to meet you all. Some of you I've met before. Stuart, Andrew, Rod, David. Obviously Frank and Kim, thank you for having me. Yeah, my name's Christina Herbers. I'm just excited to be on this team. I guess I've been in the industry since I graduated with my BSc in mechanical engineering co-op in 2000. I specialized in district heating, district cooling for 10 years, and got my lead. So obviously really interested in green buildings and everything. I'm currently the ASHRAE Northern Alberta chapter president. So if there's anything you guys want me to bring to ASHRAE, let me know. So yeah, we wanted to go really high level for heating, cooling, ventilation, humidifying, and domestic hot water. So my presentation just was really high level, and I'm trying to talk fast because there's lots of technology. And I left the costs out of this at this point, just because it depends on like the quantity you're purchasing, and sizing and everything like that. But if you guys need that, I can send that to you. So one of the technologies we've been talking about with Frank is an Ortec solution. So it'd be an Ortec heat pump, all in one compact solution, providing both your heating and your cooling. no outdoor unit needed. This would be for your fourplex. Well, this could be for either your fourplex or your other suites. Venting is just through these two small wall ducts. And it has a drain pan heater, so perfect for multifamily homes. This was created for multifamily solutions. And then pair this with an ERV. So I basically started with our lowest cost solution and I went to our highest cost. So this one is the lowest cost solution. Your ERV could provide between 80 CFM to 150. This one has a cross flow core. It's low voltage. But the main benefit is there's no outdoor unit needed. So yeah, this would be our Ortec solution, lowest cost. Then I would move up to our Swagon solution. So this would be a Swagon Casa high efficiency, over 85% efficient ERV with a heat pump and fan coil probably as well, or baseboard. This one would come with your electric or hydronic heating coil, depending if we're having a small boiler or not. This ERV uses an energy recovery wheel, so that's how it controls the humidity, is with that. The unit I've selected is supply airflow up to 170, but obviously we'd have to dive into the loads exactly. Nice thing about this one is it can tie into your bathroom exhaust and delete all your bathroom fans. This one comes with fully onboard controls. And then you would have your indoor DX evap coil plus your outdoor condensing unit. This one would be higher efficiency and a little bit higher cost than the Ortec. And then hot off the press, we just partnered with Zamba. Okay, so Zamba, if you haven't heard of it before, was created by a consultant out of Vancouver. He was a consultant for a long time and then found the need that, we want to do ventilation, heating, air conditioning all in one. So he partnered with a gentleman and they came up with this Zamba. So it's just being released to the market now. And this would be perfect for our fourplex. Again, I started lowest cost and going to highest cost. So this is architects are really liking this. So your increased floor to ceiling height. We are designing some high rises with this, mid rise. And I think it would obviously look beautiful in the fourplex as well. So everything is contained in your small unit here, your high efficiency ERV, your supply air fan, your filters, your fan activated chilled beam, heat pump, and your free cooling. So this one provides a boost up to 400 CFM and your lowest would be 15 CFM. Total heating 13,000 BTU hours and total that was total cooling, and total heating 11,500. So, and you can come up with any aesthetic or customizable surface finish to hide the HVAC, or you can integrate it into your wall. Anyway, really excited to offer Zamba. And then another thing I thought about for the ADUs is our Lunos solution. So our Lunos ERV is a through wall ductless ERV for those low ventilation loads. I didn't totally see the ventilation loads here, but a couple pairs of this could do all of your ventilation needs for the space. And you could, and it's low voltage, it's just 12 volt low voltage wiring with either a fan coil or hydronic baseboard or electric baseboard, whichever way we're going. So that is my quick overview of some of the solutions we have. No, and I want to throw in one more for your domestic hot water. I'd have to look more closer at your total. I didn't see the total domestic hot water load, but we have air source and water source domestic hot water heat pumps. And I think in this case, it would be probably used for the whole complex and you know, appropriately sized storage tank for the I think there'd be six families in this, the fourplex plus the two. Yeah, so 6. So once we come up with a load, then, you know, Colmac, we have multiple of these units installed throughout BC and Alberta. Back to Lunos, we have 18,000 pairs of these at the U of A residence building, serving the students. And yeah, we are HVAC systems. We have offices in Edmonton and Calgary. Yeah, our website is a great resources, and that is all I wanted to say at this point because I had 5 minutes. Hopefully I didn't go way over.
No, you
Thank
did
you.
perfect.
Thank you,
Okay.
Christina. Yeah, go ahead, Frank.
Yeah, I guess one quick one, that Zamba, is it a split system, or is it is a heat pump in the unit? Like, is it
Heat pumps in the unit.
Okay.
Yeah.
Interesting? Yeah, seems to be lots of those ones coming out, and it's certified, so it's got all its ULC certifications.
Absolutely.
So, Frank, would we
Excellent.
like to do the questions after each presentation or put them all at the end?
If there's anything specific, I think we
Yep,
can ask them
there's a
now.
couple. Yep.
Okay.
Yep. So the other one was about the Lunos and its certification in Alberta. And so that you said there were quite a few at U of A. And
Absolutely certified for Alberta. And
Okay.
what we did, certified in Canada, certified down to minus 35 degrees C. It's been in operation at the U of A for 4 years now, 4 to 5 years now. And what we did is so it's a reverse flow core. So kind of like your anyway, it's a reverse flow core, so you have to maintain your temperature in your space. And then we played around with, well, we didn't play around, but we along with the designer came up with the right amount of time where it exhausts and the right amount of time that it returns back. So it's about a 90-second airflow switching to maintain the proper efficiency. But yes, absolutely certified in Canada and Alberta.
Okay.
Excellent.
So Andrew Peel's going to be the next presenter. And if there are any other questions, please just reply to Christine. I had a little chat started under Christina. So if you have questions for her in particular, then it's easier for us to sort them. So Andrew Peel's going to present now, and same thing, I'm going to start a chat for him. And if you have any questions for Andrew, you can put that in right in the chat. Okay.
Okay, hear me?
Yep, we can hear you. We can see you. Looks good.
Excellent. Okay, good. Well, thank you for having me. So excited to present this. It's an innovative HVAC solution. We actually have a research project going on. It's funded by CMHC at the moment. So this is good timing. Just a bit of background for those who don't know Peel Passive House Consulting. We're basically a firm focused on helping folks implement the Passive House building standard, working as consultants, as building certifiers. We also work with manufacturers to assess and advance their products to meet Passive House requirements, and do a variety of other things like training and research. So what we're doing is trying to address actually this barrier, particularly around multifamily. So our solution is focused on multifamily. You could see how it could stretch to an ADU. But essentially, I think we recognize the problem, the expense, the challenge. Typically we have 3 separate systems to provide heating, cooling, domestic hot water, humidification, all that. As Frank was describing, we got a separate ventilation system. We have typically an air-to-air heat pump for heating and cooling. And if we want to fully electrify, we have this additional heat pump, air to water heat pump, typically to produce our hot water, right? All these systems, typically they're not necessarily sized load wise for the substantially decreased loads of Passive House net zero ready buildings. So yeah, we don't see any capital cost savings that we were promised with Passive House, particularly multifamily. So what we're proposing is to implement this strategy called cold air distribution. And this is actually a strategy from the commercial and industrial building sectors that's actually applied. It's been successful, and actually ASHRAE even has a design guide on cold air distribution, right? And this is essentially supercooling our supply air, which in this case is going to be our ventilation air. I could speak for hours about this, and I have some further background, so there may be some questions that come up. Just for sake of brevity, I've taken out a bunch of background on this. But essentially, according to ASHRAE, CAD, cold air distribution, can actually lower mechanical costs and reduce energy consumption. So essentially, what we're trying to do is instead of these three separate systems is have something a bit more integrated. So switching to an air to water heat pump, a central heat pump that's actually going to provide heating or cooling, chilled water, heated water to our ventilation system as the delivery mechanism for heating and cooling. And at the same time, it can provide the domestic hot water as well, right? Yeah, and so kind of general schematic. This is probably a lot to try and take in a presentation, so I'll try to encapsulate it as best I can in a short period. But essentially, we have our centralized heat pump, indoor-outdoor unit, right? We have two tanks, a tank for domestic hot water, and then a tank that would either be storing heated water or chilled water, depending on our season. Especially these small multifamily, I think they work well with a central ERV, and that would be one way we could potentially reduce costs, is to have a shared ERV across the 4 suites. And so that would be delivering our fresh air, but at the same time, we're going to have a passive coil, so not like a fan coil unit, but actually just a passive coil that air flows through, and then we feed either heated water or chilled water to that coil. That heats or chills the fresh air that's coming into each suite. So there is, although it's a centralized system, we would have individual control of heating and cooling in each suite through a passive coil in each suite. Okay. Here's just a list of the kind of specs we've come up with for some of the projects. We actually have 7 projects now that are implementing this solution coast to coast, from Victoria, BC to Margaree, Nova Scotia, including a project in Edmonton. Although the Edmonton project's a bit different because they're actually opting for geothermal. So our system or general approach could work with geothermal as well. But certainly from a cost perspective, we'd be looking more for an air-based solution. Yeah, I won't go into details of these specific products, but there are different variants of our solution that we could, well, I'll talk a bit about the individual components here. There are, I'd say, optional items that we could look at from a cost perspective, whether it makes sense or is what's a trade-off for cost, energy savings, and sizings of systems and so on. But essentially, we'd have a air to water heat pump. The unit we've actually specified is a unit from Spain, because it was the only one we could find really that could do the span of all 3 services: the heating, the cooling, and the domestic hot water fully. Except for when you get into really cold temperatures, which is a problem in general for air-based heat pumps. And the heat pump we've landed on is actually a propane-based refrigerant heat pump. So that's something we navigate with if there's any challenges with local jurisdictions or building codes. But so far, we haven't had any issues with that. There is a benefit to propane in that extended range, colder water and also hotter water. That's why it can actually do all of the domestic hot water as well. And then the idea is this is a newer solution, so we're having to engineer it, but we are trying to use commercially available pieces of equipment. But the idea is that we want to expand this over time as we further and further demonstrate the feasibility of this solution, that other manufacturers there might be other products that fit beyond what we found in the market, or manufacturers may be willing to actually modify enhanced products to meet the specifications we need. But yeah, and then just a note about load analysis. So we did note that the loads are, I mean, these weren't designed as passive house buildings. I think, you know, and it's great to see Rod Nadeau on the call. I don't know if he's presenting, but he can certainly talk about, you know, cost optimization of the building envelope and really low, you know, reducing the delta between code conventional and, you know, passive house type envelope performance. But I think so, you know, there's probably an optimization in terms of envelope performance, as well as a refinement of load analysis, because we do find the kind of code compliant load analysis tends to be conservative on the loads that it reports, compared to, you know, passive house analysis, you know, and passive house analysis adopted for North American conditions, including internal loads. So like there's could be some refinement there as well. And that would certainly, for our solution, we'd need to do that refinement to see how we can land depending on what the specifications are of the building envelope. And then another thing is just solar protection. This solution does have limited cooling capacity. And so we'd certainly want to make sure that we don't have an excessive amount of solar gains in the building, because, you know, heating is easy to augment a bit with any, you know, say electric resistance as needed in the really cool periods, but cooling is certainly not. So yeah, I won't spend much time on that. In terms of the ADU, our solution isn't necessarily the best fit. If the ADU is close enough to the 4-unit project, you know, we could potentially extend it to serve the ADU as well. Otherwise, I was just, you know, musing on some alternatives that could be implemented, which some of them not the same technologies or same products, but there were certainly some similar ideas in terms of heat pumps through in-room heat pumps that avoid split systems. So that could be explored as well. But yeah, maybe I won't spend too much time on these elements. There, you know, there's opportunities also with domestic drain water heat recovery to potentially help optimize loads and system sizing as well. Yeah, and I think maybe I'll hold it there as well. Again, lots to talk about. And I just want to acknowledge both CMHC and Syria for providing funding to help us support the development of this solution. And I will end there. Hopefully I'm good on time.
You were perfect again.
All right.
Thank you,
Excellent.
Andrew.
Yeah. So again, we can't get all the specs in 10 minutes. So that's why we'll come up with a report where we can check back with everyone and get some more detailed specs and make sure we're being as kind of as thorough as possible when we send this information out to everyone. Yeah. So Haley, I'm sure Andrew can send the specs of the equipment later. Any other specific?
Yeah, there were some other questions, Frank. Do you want to do them now or at the end?
Maybe let's bump them to the end because I think we still have a few more presenters.
Yeah, we do. Yeah. Okay. So next up is David Walker. And for any of these presentations, I've started a chat and with their names at the top, and you can ask your questions there, and then we'll try not to miss you later. Okay. So I think David, you just need to click on the share button. You've got your presentation queued up. Let's find David. Is he?
Yeah, I'm just not seeing a share button anyway.
There you are. Okay.
Generally,
it's at the bottom. It's at the bottom. It's the little green button at the bottom of your window. So look down, maybe look down a little bit at the bottom, underneath everybody's names and the participants. So it's the whole bottom menu. The green button that says chat.
Or David, I can pull it up since you sent it to me beforehand if you want.
Yeah, I know I made a couple of
That'd
minor
be handy.
changes, but you can do that.
That'd be handy.
Does that look good to everyone?
Good. Thank you.
Yeah, yes, we can skip through. Yeah, we're just going to do a quick overview. We'll know what we're talking about there. So yeah, in today's market, a lot of owners are looking for electrification. With the advancement in different technologies, especially heat pump technology, we do have viable alternatives now to traditional gas systems that are capable of dealing with the typical Alberta winter. Okay, so for the main fourplex, for the main floor and basement, one of the things I was sort of trying to keep in mind was for this is affordable housing, like keeping the costs down. So it's sort of a very economical option. It's like a 3-ton outdoor unit with like furnace style indoor unit air handler, which does come with a electric backup heat if required, and we can sort of duct it around the space as needed. Okay. Yeah. And next slide, Frank. Okay. For the upper floors, we'd do with more of a multi-zone system with a ducted unit in each space. Again, we've got the 1-ton head in the space with a 2.5-ton outdoor unit to allow for full capacity at traditional Alberta winter conditions. Okay. Okay, and then for the ADUs, as it's more of an open space, we could go with a similar type system with a wall-mounted head in each suite, just to take care of everything. Okay. For ventilation, one of the things that is often overlooked is the ability to recover humidity. I know we're going to sort of talk about the humidity a bit later on, but with an ERV, we're able to recover sort of the latent energy as well, which is critical in this market. So yeah, for the similar sort of systems here, we've got the Aldes energy recovery units. They come with a variety of options for filtration. Standard is MERV 6, but MERV 8 and MERV 13 is also available. Like these units also have easily adjustable connections, like the picture shows horizontal connections. Those connectors just click off and you can change it to a vertical connection straight away. Also, these are available with ECM motors if wanted, instead of the standard 3-speed PSCs. So yeah, this one does about 150 CFM, at full speed for the main floors and basement to serve the various areas. We've got a slightly smaller unit on the next slide for the upper floors or for the ADUs. Okay. Domestic hot water. Again, standby losses are a consideration. Recovery rates, also tank warranties, something to look at. Okay. I've looked at hybrid electric and point of use. I typically would lean towards an electric storage tank for these type of facilities. There is an advantage with the hybrid electric where during the summer months it does actually provide cooling. It's pulling heat from the space and putting it into the water. On the flip side, during the winter, it's pulling heat from the space that you're having to then replace with your heating system. Okay. So yeah, if we look at the next slide. So yeah, like the standard electric gives you sort of a steady 21 GPM, and like a 10-year, comes with a 10-year warranty. Okay, and we'd have one of those in each of the spaces. Humidification, we touched on humidification. There's various types of humidifiers around. I personally prefer the like the Aprilaire option here, that's a steam injection. It gives you a lot more control, a lot higher efficiency. It's like steam is injected into the airstream. For the ADU, where we don't have ductwork going around, you can get it with a fan pack to provide humidity into the space. Highly important in today's thing for electronics, hardwood flooring, sort of becomes more and more critical. However, you do need to control that so you don't have water running down windows and stuff. So, okay. Put together some rough equipment only costs. I would stress that these are effective today. There's certain political things going on, especially with the states, that I can't guarantee these beyond tomorrow. It depends what happens politically. But yeah, based on the systems we described, to provide heating and cooling, we're looking at like $5,500 for the equipment. Energy recovery, sort of 1,800 roughly. Humidification, 1,200, and those domestic hot water tanks, the electric, around about $1,000 for the fourplex. Numbers sort of stay fairly similar. We're looking for like about $3,500 for the heating and cooling, and the ADUs about $2,500 for the heating and cooling. Okay. So yeah, David with MCO Applied. My email's there. If anybody wants to get hold of me, happy to answer any questions. Okay, thank you very much.
Okay, I think we'll hold the questions till after the next presentation. And I think Kanan, if I'm not saying that right, you have a presentation to share?
Yeah, hi.
Hi.
Hi, this is Vasilis and Kanan. We're with Klima Design Technologies. We're the Innova distributor in BC and Alberta. Thank you for having us and for the opportunity to present some of our products. Innova and actually we can share the presentation.
There's a button at the bottom that says share. It's green, it's lit up in green.
Yeah.
Can you see that?
Can you see that?
Can you see our screen? No,
Not yet.
Open the, go back to the meeting.
Great, good.
Yeah.
Can
Are you able to?
Can you see our screen? I'm not sure how it.
Yep, we can.
Yeah, you
It's-
can. Okay.
Hit the switch on display settings, hit the switch presenter and the other one.
Sorry.
On the display settings. No, up. Display settings right there. Flip. Swap presenter and view slideshow. Flip that. There, perfect.
Yeah, it works now.
Yep, perfect.
Yep.
Perfect. So we're gonna what we're gonna present is the Innova products. If you're not familiar with Innova, Innova is a premium manufacturer from Italy, leader in the PTAC market and high efficiency solutions. I think there are more than 20,000 units right now installed in BC and Alberta. There's a few options here that we can discuss, some high-level solutions. We wanted to clarify a couple of things. Obviously, the intention is to go electric only, and then there's, especially for the heating side of things, it can be only heat pump and electric backup, or a combination of any combination we want to do. I think for the idea from our side is to, in general, just keep things simple and have a solution that's going to be cost effective, high efficiency, and also just simple and easy installation. Anyone can install these units, and there's no refrigeration lines, there's nothing very complex, low maintenance, just washable filters and things like that. So it's very, very easy for the end user and very cost effective. For the ADU unit, I think it's a pretty straightforward option. We have we have the 2.0 heat pump. It's either there's a wall mount version and there's a vertical version as well. Wall mount is the most typical one, but in some cases, depending on the floor, the layout, architectural details, and things like that, the vertical version is also a good option. This is just a schedule there with the BTUs and the load. And I think for these units is pretty simple, like one unit.
Yes.
The smaller one, the 12 HP, there's a bigger unit as well, the 15. Like the smaller unit's gonna do the job both for cooling and heating, because the 2.0 units also come with electric heat strips. So there's a electric backup for just supplementary heating. Again, depending on what we're trying to do here, we can also, these units can be interlocked with the just the standard baseboard heaters or any other electric heat. So there's we can provide the central wall controller that can interlock with the baseboard, and it can control both the Innova unit and any other source of heat in the space. So typically what we see is just a PTAC unit for the cooling and heating, and maybe a separate supplementary baseboard heater for the bedroom.
Yeah.
That's typical how we see the design. And again, this type of a scenario is very popular for any type of housing, affordable housing. It's specified from BC housing because it's just it's cost effective and very energy efficient.
Yeah.
Anything
Actually, so the dwelling unit, actually, the space is pretty much compact, and the cooling and heating load, which was mentioned, around 6,000 BTUs, And these units can produce like up to 8,500 BTUs for the heating and cooling. So pretty much like this unit alone is like pretty much good enough for the cooling. But as the dwelling design is like composed of like a living and a bedroom area, just for the heating, actually it is the unit itself is good enough. But in case like it's a bedroom as a separate area, like we can propose like a baseboard heater on the bedroom just for the heating. But for the cooling, actually just with one unit, like we will be able to do it. And as it said, there is no outdoor connection, like it's just like all in one unit, like everything is like indoor. We are hanging it on the ceiling or like on the wall with two 6-inch ducts outside.
So yeah, these are some different
options,
configurations. Yeah. From the left to the right, so it's the small unit, and the second is the 12 HP, which is it's 9,000. Yeah,
9,000. Sorry. So this like this is the different models of the wall mounted, the 2.0 models. Actually, the first one is mini, like which is 9 HP, which like a nominal capacity of the, like with the heat pump, it will be like around like 6,000 BTUs, and 12 HP, which is the model like which is the most moving model, which have around 8,500 BTUs, and this is the capacity. This is the model which we are proposing for these dwelling units. And 15 HP is the same dimension, but a higher capacity compressor inside, which gives you around 12,000 BTUs of heating and cooling capacity. And the vertical one, which is like a more compact unit, like where you don't have a wall space for the horizontal one, this can go. And it's again like the same capacity of 12 HP.
Because sometimes they have like a slider or like a not enough space, or like under the window, or and they just go with a vertical configuration, which is popular as well.
Yeah.
Cannon, do you sorry, I just need to cut you off. We're getting close to time. Do you have a slide with any rough budgets? If not, we can kind of follow up with more information for the report. But yeah, I need to cut you off pretty quick to get other people.
Let's keep this quick. So again, some dimensions, we can provide any additional information in the future. There's how it's built, just some main components as well.
Just some of the features, actually.
Some of the features, and also there's Wi-Fi connection.
Wi-Fi connection and the app facility for this.
Like there's an app, like a mobile, you can control from the app. You can control from like the display from the unit, or remote wall controller. Like there's many options. Just the performance, like data sheets, technical data sheets, and this is pictures. The vertical and the wall mount, and now for the fourplex, there's two options. One is to again stay with the Innova, the 2.0 unit, PTAC unit, and then similar to the smaller unit, the fresher will be just managed like with a different unit, like same like a typical application. Like there's many.
Okay, Cohen, unfortunately I do got to cut you off. We got a few more things to do, so we can definitely send us all these slides. We will send them out to everyone afterwards, but we have a few more proposals to get through, and we still want to get to that discussions. So sorry to cut you off there, but yeah, Matt and Rod still have presentations, so maybe 5 minutes each. Thank you. So very briefly, that was a combined ERV and heat pump with electric resistance backup, all in one small unit.
And please do send put your questions in the reply to the presentation. So Matt, you're up next, if that's okay.
And can you hit the stop share? I think Matt might kick you off anyways. Perfect.
All right. Okay. Can everyone hear me and hopefully see some slides?
Yep. Just hit the present.
Perfect. Great.
Excellent.
Awesome.
All right. Short and sweet.
Short and sweet. Sounds good. So I've just got some very high level schematics for a few different options for the fourplex that I was thinking of, and then a couple for the ADU. So fourplex actually, so we're just trialing on a couple of projects now, some of these kind of integrated heat pumps with ERVs. So we've got one project that's using the Innova HRAI Plus units, and then another that's using the Minutair units to combine that heating and cooling with an ERV. So this is my first proposal, is if we were doing more of a hybrid system, we could use these combined heat pump ERVs in each suite for cooling and fresh air and some heating of the supply air. And then we could have as a backup heat, we could have a central gas combi boiler that would be doing some in-floor heat that would carry our heating load in cold weather. And then it would also provide our domestic hot water centrally. So that's one option. We could also switch this out to be fully electric with a central air source heat pump. You could even switch that to a ground source heat pump, but same idea. We've got our cooling supplied with these heat pump ERV units, and then that central air source heat pump is just focused on heating and domestic hot water. It does simplify the controls a little bit because we just have a hot tank. We don't have to switch between hot and cold for that central system. Another thought I had was we could just do completely central for our heating and our cooling. And the benefit here is we get to switch to just a regular ERV. So we don't need a fancy heat pump ERV. We can switch to more of a traditional ERV and then have a post coil on it, similar to what Andrew was proposing. So those were kind of the three systems that I was thinking of that have a centralized component. And then one that's completely decentralized would just be those heat pump ERVs in the two top suites because they've got small enough loads for them, with electric domestic hot water tanks because they've got pretty small hot water loads. And then on the main floor units, I propose having ERVs feeding into an air handler with an air source heat pump and a separate heat pump hot water heater. So this is kind of what we would design for like a larger house as well. And so if we were doing a completely decentralized system, this would be my proposal for that. And then for the additional dwelling unit, again, I do think that these heat pump ERV combo units are pretty nice and fit well with that type of unit. I like them because you can duct to all the rooms still if you want, if you've got a couple of different rooms, and it's nice and integrated. You don't have to have like a separate baseboard heater that's not as well integrated. So this would be my kind of preferred proposal, but a second option would be to go with more of a traditional mini split, regular ERV, and then backup baseboard resistance. And yeah, I think we've heard about Innova already. We're trying the Minutair Pentacare on a project, so it's just getting under construction shortly. So I'm curious to see how that one goes. And then also we're looking at this heat pump on a project that's just under construction as well. This one seems interesting in that you can do a hybrid system where it's actually providing, you can have an air source component and a ground source component to deal with an imbalance of load. So if you've got a heating load that's much higher than your cooling load, you can actually balance them a little better with both air and ground source. And let's call that good. Hopefully that's 5 minutes.
Perfect. Perfect.
Awesome.
I think you were less than 5 minutes. Thank you so much.
Amazing.
It's awesome. Rod, you are up next. And then Isaac, if you have a presentation, do you?
And just to clarify, the APOCA is the Innova. It's just the name changes when it comes to Canada.
But I don't have anything prepared.
Okay, that's fine. Thank you, Isaac. Okay.
Okay, I think, am I sharing my screen right now? Did I get that done right?
Yep, you look good. 5
Perfect.
minutes, short and sweet.
Okay, well, I'm not selling anything. I'm not a supplier. I'm just a builder. And I've actually used most of the products people have been talking about. And in their applications, they've all worked fairly well for us. Quick history, 2018, this is the first building we did a central system in. and we used a Swagon ERV as the air handler for heating, cooling, and ventilation. And we had BCIT work with us for 3 years, doing energy modeling and helping us design the building for the most cost-effective solutions to building high-performance buildings. And somebody mentioned that the ERV didn't make that much difference between 60 and 80%. In that building there, we found the ERV was the best place to spend extra money. Over 25 years, going from a 55% to an 85% ERV, we're going to save $130,000 in energy costs. So it was the biggest energy savings is having a high performance ERV. Then we built this building. This is where we really got it all together. Central ERV that does heating, cooling, ventilation, corridor pressurization. And then we use the sand and heat pumps there for hot water. We've got a lot of experience now in running these central systems. But our building cost us 32% less to build than a code minimum building. So there is no case on Part 3 buildings where you have to spend more money to build to a Passivhaus standard. And that building, the units heat for $30 to $50 a year, and they cool for $20 to $30 a year. Here's our next project in Golden, smaller building, same approach. We used the Swagon ERV again for heating, cooling, ventilation, and tuning that in. It's working very well. So there's just a couple of pictures. You can see the Swagon. We put a preheater on, which is the best way to deal with frost, but it only really comes on below -20. With the wheel, it's probably the best cold climate way to use your ERV in cold climates. Central ducts, we take everything down to 5-inch ducts by the time we go to the units, because then we don't need fire and smoke dampers, where we penetrate all our fire separations. So as long as you're a 5-inch metal duct, you don't need to put all the fire dampers in. And then up in our mechanical room is where we have all the fire dampers, where it leaves the mechanical room, and the balancing dampers. There's just a quick picture of the sand-ins. So those 4 sand-ins are doing 30 units for hot water. The only issue we have with the sand-ins is there is water out there. So we heat trace the water lines, insulate them, and then we have this little UPS backup system. But the most heat loss in these multi-unit buildings is actually in the recirculation system. So we spend a lot of effort making sure they're really well insulated, and that has saved us a ton of money in the multi-systems. There's just some library of design buildings that we're going to be selling our high-performance designs and approach to building. So now getting down to fourplexes and smaller buildings. This is just a 10-ton system. It's going to do 25 units in a high-performance building. It'll do the heating, it'll do the cooling, and then we will have 3 ERVs. There'll be the CASA ERVs that Christina was talking about, their largest model, and that gives us zone control between north, east, south, and west units in the building. So we just stack them vertically, and they're actually less cost than running the larger Swagon units, and we get a little more control. And we're just going to use the Arctic heat pumps, Canadian company. They'll supply everything in this picture, including a little backup heater to run it. And then it'll run off to, here's the system we're going to use in a fourplex with just 1 5-ton. And in the fourplexes and in the larger building, we just run it off to 4 air handlers. In the fourplex, we'll have 4 small air handlers and a central ERV that will feed into the return air on the air handlers. In the larger building, we'll use the CASA ERVs as the air handler. So then we skip out in this step. The fourplexes, they'll all have individual thermostats. In our larger buildings, we put a little 500-watt baseboard heater in and a thermostat on that. But the central system, once you have a high-performance building envelope, we just dial it in at 21 to 22 degrees year round, and we're done. And we've had absolutely no complaints in our buildings in the last, well, 8 years for the first one, and 5 years for the second one, and 2 years for the third one now. So the high performance building envelope is what really makes the temperatures very uniform in these buildings. And so you don't need a lot of sophisticated controls to make it work. And we overventilate. So we just run the ventilation 24/7 at a higher rate. But one of the more important things is we always use MERV 13 filters, because that is the filter that will start to filter out wildfire particulate. So in wildfire events, which we're all now familiar with too often, and a lot of smoke, you can have some healthy indoor air. There's a picture of the little CASA unit that we're going to be using. And there's some duplexes we're building up at Kicking Horse. It's cold there. It's just like Alberta. It's almost in Alberta. And in those duplexes, we're just running a little 3-ton heat pump, and that will do our heating and cooling. We opted for an air handling unit because the problem we found with all the other units is they're just too big for the bedrooms and other rooms. So we're just ducting this like a standard furnace, because, you know, we only need 50 CFM of air to provide enough heating and cooling to keep these places going. I just pulled this picture off the Senville website for a 4-ton with 10 kilowatts of backup heat in the air handler. And it's actually a Midea, which is a Lennox, which is a dozen other private label brands. So this equipment is pretty standard. You can buy it anywhere across the country from a variety of different suppliers with a variety of different names. But the guts of all this stuff is probably made by 3 or 4 companies around the world. And so that is kind of my little presentation. We've been doing this for 30 years now, and I've tried almost everything in the way of building envelopes and high performance buildings and a whole variety of equipment. And we've kind of narrowed it down to using an air handler in the larger units for better distribution. In our buildings, we do a central system. And the nice thing about that Arctic heat pump setup is we also get hot water out of that. So we have one heat pump that does heating, cooling, and hot water. And then we just throw a little backup boiler in. And in the 4-plex, the backup boiler will just be a 60-gallon electric hot water tank, which is a stock item you can just buy anywhere.
Excellent.
So that's it.
Great. Thank you, Rob. Alrighty, I think
Thank you,
that's all
Rob.
for the presentations.
I think it is. Yeah. Do we want to go through the questions, or do you want to do a little bit more, Frank?
I think some of the questions actually kind of roll into some of our kind of discussion questions. So why don't we actually, unless anyone needs a break, why don't we roll into our discussion questions to keep us going? All right, so at the very beginning, I kind of prefaced, do we want all electric? And if we weren't in Alberta or Saskatchewan, where any of those the green ones like Ontario, BC, Quebec, and Manitoba, I think the answer is fairly easy. We go all electric. The problem is Alberta's electrical grid is still fairly dirty. So is Saskatchewan's. We have been getting better. The numbers, we'll see in the next slide, vary. We've been dropping as we've now removed coal from the Alberta grid. And we're up to about 22% renewables, but the rest of it is now pretty much all natural gas. So unfortunately, the electrical grid grams of CO2 equivalent per kilowatt hour is anywhere between 540 and down to 300 grams, depending on which government source you look at. And the natural gas grid is 1,962 grams per meter cube. Once you convert that to kilowatt hours, it's only 189. So right now in Alberta, the natural gas grid is 1/2 to 1/3 the CO2 emissions of our electrical grid. So unless we're getting COPs, seasonal COPs of 2 or 3 or more, natural gas is a lower carbon option right now. Hopefully that will drop in the future. So based on that, I'll have maybe a little bit of conversation on, is complete electrification of a buildings a goal we should be pursuing in Alberta right now for these kind of missing middle projects? If you want to type, you can type. If you want to unmute, unmute or put your hand up. What do people think? I would like to just be all electric, but I'm not sure anymore.
Before we jump into the questions, Frank, I just want to be sure everybody's okay with not taking a break. Is everybody okay with that? Okay. Okay. Just want to be sure. Okay, let's go. Yes, you can put your hand up, or you can type in the chat. And don't all speak at once.
Nothing? Are we just depressed?
Yes.
Go ahead, Haley.
Sorry, I wasn't putting my hand up for are we just depressed? Yeah, I think obviously electrification with adding renewable energy production on site would be the way to go currently. And then additionally, like, yeah, some of the predictions may be wrong, but we are cleaning up the grid relatively fast, just with improvements being made in the next like 10 years. So, I mean, that's just something to consider when you're installing a system right now that's going to be used over the lifetime of the building, right? So that's my 2 cents.
Yeah, build for the grid we want, not the grid we have right now. Steve, would you next, or Isaac, or Stuart?
Did you unmute? Okay.
Want me to talk
Steve?
next? Or Stuart?
Sure, go ahead, Isaac.
Oh, okay, I guess we're talking about electrification versus gas. I have lots of opinions for people that know me, but I think both options are the right way to go right now, depending on where you are and who the client is in the house, right? So a hybrid gas heat pump option is fantastic. You can keep that COP really high to cold temperatures and then switch over to gas when you drop your COP on a standard build a house. But if you have solar, all electric starts to make a whole lot of sense, right? You can offset with your solar panels, or if you have geothermal, you can keep your COP up. So I don't know. I'm with you, Frank. We should electrify, but I think it's best of both options depending on the circumstances.
Excellent. Stuart.
I would agree that you should electrify. I think with a new build where you've got control of the envelope and you're going to push that performance to where you have, if you can make the economics in operation electrified versus gas, at least net out, if not be better, then you're winning in the short term. And then 100% we have to commit to an electrified future. And so we need to build things that lead in that direction. If you're going to put in mechanical infrastructure that's good for 20 plus years, definitely over that time span, I think we're going to see big changes where the grid changes. You can obviously put solar on the roof to offset your footprint now. I think the hybrid solution is good for retrofits where you can't do the envelope first. If you are trying to green up your mechanical before the envelope performance is there, that's where the gas heat pump hybrid is ideal.
Thank you.
Awesome. Saffron. Saffron, you can unmute.
Oh, we can't hear you for some reason.
For some reason. That's because I think she's in New Zealand. So maybe your volume is not up, Saffron.
I'll put it in the chat.
There we
There we
go.
are.
Now we got you. Perfect.
There we go. Perfect. Yeah, sorry guys, I'm in New Zealand. It's like 6:30 in the morning here, but so I'm coming at it from the building envelope side, and the question about whether we go electrification or natural gas, I find to be the incorrect way of putting it, because I think that in both cases, what you're actually trying to do is reduce your energy consumption. So though it's great that we're trying to focus on electrification, natural gas is not as bad of an option as, for example, coal. Our grid is moving in the right direction, but no matter what we're doing for energy consumption, having less consumption is better than trying to optimize the dirtiness, the consumption that you have. So I'd be more concerned about, in the 20-year lifespan of these mechanical systems, how are they optimized with the envelope? How are they going to degrade in performance over time? Because I'd really rather us focus on just consuming less rather than trying to nitpick where that consumption comes from.
Yep, definitely still efficiency first.
So that's building envelope first is what we're talking about, and efficiency of the equipment. So we're on discussion question 2. And so this is, we've talked about it a little bit with everybody, but the dual fuel systems. So does anybody else have anything to add about dual fuel systems? So Matthew first, Matt.
Sure. I just wanted to, like, maybe one consideration too that I think of in terms of electrification or dual fuel would be making sure we're designing systems that are not going to be too challenging in terms of the grid's peak on cold days. So I do like something like a hydronic system where you can have some buffering capacity, or you're making sure we're putting in some thermal mass and or even geothermal where we're contributing less to the grid's peak on the coldest day. So that's maybe a little bit more to the electrification question, but I think it ties in with dual fuel too.
Great.
Excellent.
Okay,
Thank you.
Rod's next.
We have done all electric buildings for the last 10 years, and we find it's less expensive to not have to have dual equipment. And we've needed very little backup heating, even when it's hit -40 in our golden projects. And if your grid is dirty and you're using electricity, well, as the grid cleans up, electricity is one of the few things that has multiple sources. You can have clean electricity from your roof. You can, as the grid cleans up, the electricity will get cleaner. But if you put in gas equipment, then you're on that gas equipment for the next 20 to 25 years.
I've got a question for everybody because we have so many smart people here and experienced people. Do we know of very many, besides Rod's projects, multifamily projects that are all electric? I think Stuart might be able to address that. Somebody else in the group.
We've done quite a few.
Multifamily?
Yeah.
Okay.
Yeah, we have a
Yeah.
small, I can provide you with a list, Kim, if that would be helpful.
I think so. I think so for the sake of this, that'd be great.
Okay.
Okay. And kind of the idea of what the loads are, etc. And so the pushback for using gas often is that nobody does this, or it's not possible to do those kinds of arguments. And there's a real default to going to gas or dual fuel systems. So, okay.
Yeah,
I
just
think you
on
have
that, we've got about 8 multifamily projects on the go this year. They're all electric, no gas going to them at all. So it's very easily doable, and it's becoming more and more prevalent. I think people are starting to go that direction.
Great. Okay.
I think it's really a question of scale. You have to watch the intensity and the utility rate structure that you'll end up. What's the metering structure? Like at the scale of this, the missing middle, electrically, you're going to be on residential rate class electrically, and that's like you're laughing. Like your economics are great. There's no demand charges. Everything's good. As you scale up, as you get, and this is jurisdictionally different, but if in Alberta you get over the 50 kVA utility size, now you've entered the world of demand charges, and the bigger you get, the scarier that gets, and it can have a 10 factor impact on the op costs. The worst case that you can do is have like electric peaking on a large scale project, like electric heat peaking in the winter on a large scale project that has demand charges that can turn your economics upside down. And so that's where we see geothermal come into the conversation. Like the economics of geothermal on the missing middle are not great compared to all the air source stuff we have today. But once you get into a rate class that has demand charges, geothermal looks really, really good.
That's awesome to know. Rod, do you still have your hand up, or do you have another comment?
A comment on the demand charge. We have found in our buildings that it's very flat, hardly varies summer to winter. So when we're paying the commercial rates, the demand charge isn't really much of a factor. It still keeps us well below residential rates. The other factor, once you have a high performance building, our heat loss is only 9 watts per square foot. but our cooling load is 1.3 watts per square foot. So the cooling is actually the demand load, and that's the load that we have to size all of our equipment for. So we no longer consider heating when we're sizing the equipment. It's all about cooling now. And we substantially reduce our cooling load by just having very low solar heat gain windows, which is the cheapest option you can possibly do to lower your cooling loads.
You have to scrutinize it location by location and project by project. I agree that in Golden, and if your envelope's high enough, that could be the case, Rod. If the envelope can't get that high for whatever reason, and you're in a colder climate, then it can be a different answer.
Yeah, it all depends on how well you build your envelope. The better you build the envelope, the more choices you have, and the more stable your building will be.
Matt, did you have something to say?
Yeah, just another thought to add in terms of this dual fuel piece. For some of these projects with super small loads, one challenge is finding equipment that can modulate down low enough to actually supply heat. We've had some poor experiences in the past with some very small natural gas furnaces. I won't mention the name of the company, but we spec'd them in a project. The project was very high performance, and these units spent a lot of their time in their kind of lower range of modulation, and there was no end of trouble with the exhaust icing up. And even though the mechanical contractor went back and insulated and heat traced and did all this stuff, they really struggled not to ice up because they were not putting out enough heat to keep that exhaust air warm enough so that it wouldn't freeze as it left the building. So that's something that we've experienced when trying to use natural gas on like really small, such as the ADU or even the upper units of the fourplex. So maybe just another consideration to put out there.
I couldn't agree more strongly. We have a 200 unit project that it's going to lawsuits over that. So don't use 15,000 BTU furnaces.
Yeah. Just say
Wow.
no.
Don't.
Okay, Haley.
Yeah, I was just gonna add on, when you have like a high performance building and then you're just using natural gas as a backup or secondary system, I'm wondering for the people that have had these projects in the past, like, is it worth the connection fees for using just a couple of gigajoules of natural gas a year? Like, that seems quite costly.
Yep, valid question. And yeah, so I think if we do use it, we want to use more of it. So maybe use it for domestic hot water as well. But seems like for the like that's fourplex, probably we get the envelope good enough that we don't need the gas. Probably. David and Isaac, maybe a few last comments and then we'll move on.
One thing to sort of really remember with anything, if you were looking for gas, is the transmission costs. Like we've all seen the bills coming in for electricity and gas, where it's not the use of the gas or the electricity that's actually costing us money. It's all the add-on fees. And just as somebody who sells furnaces as well, the dual fuel is a popular option. However, on these smaller systems, you really need to look at combining like all the units on the fourplex into one like furnace and go with the zoning system to get the lower loads. Yeah, I wouldn't look at trying to modulate a very small furnace.
Isaac?
I'm going to disagree with the small load furnaces and say that there's a problem on design and equipment, because I could do 4 furnaces in this fourplex and not have 0 ventilation issues throughout a -40 winter. So if you want to talk about after, we can discuss how we actually make that happen. And then on new builds, I would agree that the connection fee and running the service for gas lines, if you're doing a new build, I don't think it's worth bringing gas to the building. We can get our envelopes to a point now where we do not need gas. We have a very efficient envelope and do it with heat pumps and very little electric heat. And this fourplex right here is going to be a great example of that.
Excellent. Yeah, wanted to bring the question up, and yeah, I still like the electric option. All right, so moving on, and this, I believe we have a few inspectors from the city of Calgary and the city of Edmonton. So when we're this is starting to thinking about the combined systems, either combined specifically for this one, domestic hot water. So if we have domestic hot water, can the domestic hot water pipes, can they jump fire separations with no issues? For people who have done it, you have to fire caulk it. How costly is that? So assuming there is, all 4 suites are owned by the same individual, 1 meter, and yeah, then would a centralized domestic hot water system be better? Or would that throw wait times up depending where the units or where the fixtures are, that separate domestic hot water tanks are better? So centralized unit, domestic hot water, comments?
Yes, I'll start then. I'm a big fan of a centralized system. The fire rating, everything. I mean, I do a lot of commercial. On the commercial side, this happens all the time. So it really shouldn't be a drawback to running your water lines or any other lines from suite to suite to suite to suite. There's ways to make fire breaks and fire dampers and all that fun stuff. And centralized systems tend to be significantly more efficient, just in all ways in producing the heat and transferring the heat and all that, whether it's hydronic or a VRV, VRF system. I think central is the way to go.
Okay. Rod, then Stuart.
Well, we've been using central systems for a long time. We find them the better way to go because you can size them more appropriately. And when you have multiple units, you get some discounts because not everybody's using hot water at the same time. And in terms of fire caulking, you're fire caulking every penetration, whether it's wire, a pipe, anything between the suites anyways. So that's just standard practice in any multi-unit configured building.
Stuart?
Yeah, I agree. At the scale of 4 suites, I might price out both. Like, and it might be a question of floor area too. Like the decentralized approach might be the package air source heat pump tank, the Ream or A.O. Smith type thing. They're very cost effective, plug and play. If you have space for them, great. They make a bit of noise, so it's a consideration. But I mean, 4 of those might be $12,000. But it's at 4 suites and plus, then you might be getting into the Sandon range where that kind of technology is good. And that, puts the load off the heating system, the space heating system, like was mentioned prior, like those package units, they're just sucking heat out of the space. So you have to figure out your compounding COPs to figure out what your overall efficiencies are. But at the scale of 4+ units, yeah, I think central starts to make sense. I would price it though, and just consider those other things, space and noise.
Matt?
Yeah, I think to me, I would agree with everyone who's spoken before in terms of plumbing not being an issue, moving between suites. I do think that if we've got a central ERV, that's where we can start to run into challenges in terms of fire and smoke dampers. There's a change in the building code in the 2015 edition that requires smoke dampers wherever you have a rated wall in a residential building crossing suites, as well as fire dampers. The fire damper is a pretty simple thing, but a smoke damper costs like 10 times as much. So, so that can be a challenge. I know that Rod mentioned keeping duct sizes small enough so that you don't need fire smoke dampers. That solution does depend on your authority having jurisdiction. We've done projects where like that clause in the building code is it's fairly specific in when a 5-inch duct doesn't require a fire or smoke damper. And so we have run into challenges on projects where we're trying to do a centralized ERV and the code official is saying, nope, even though it's a 5-inch duct, it doesn't fulfill the requirements in the building code. So I understand that BC Housing has a solution that they've come up with to try and get around fire smoke dampers at every single suite. And we've tried to replicate that on some of our projects, but there is a little bit of kind of code alternate solutioning that needs to happen, which could be challenging on a small project that's just like a, you know, a fourplex. So that's been our experience with that.
Agreed. You won't get away with that in Alberta.
Oh, you
Hey,
won't, eh?
guys.
Is it worth getting requesting a stand data for that?
Good luck.
Can I say something on the City of Calgary side of stuff?
Yeah, you bet. Yes, please.
So yeah, he's 100% right. You can't do it. Like, I'll say that one ELC has now come out with some really nice fire stopping that can go quite large, but then when you're looking at residential, it ends up really heavy duct. So guys that aren't familiar with commercial have a hard time really installing that stuff. And you would need individual ventilation within your suites anyways. It's no different than a secondary suite where you have your own control. Like, because if you're pumping air into everyone's suite and bringing air back, if I burn toast in mine, you can't smell it in yours. So you have to have your own ventilation system per suite, unless you're treating it like a commercial building.
Stuart.
Yeah, you'd have to do a Part 6 design, and you'd have to use an HRV that has less than 3% leakage to be allowed to do a central unit. But
And
it
in that
adds a
case,
ton of
we
cost and
we
fire
need,
dampers
also
and
need
everything.
engineering for that, right? Like you
100%,
wouldn't be
yeah.
able to do with that.
Yeah, 100%. Yeah.
Andrew.
Yeah, I think this highlights, because this is you're trying to come up with a generic solution, generic designs, that kind of maybe there's a higher level engagement. I know the code process change, you know, it can be complicated, but if that's a fundamental issue, you know, not necessarily part of this project, but maybe there needs to be some higher level engagement on that front to address this kind of fire code issue, because that is, depending on province, that could be showstopper, that could be problematic. So there's opportunity. You know, it's like fire doesn't burn in different parts of the world, so why are there different requirements? It's kind of silly, but yeah, I think that's a key thing that needs to be addressed, because I'm on board with these. We're at a size where central makes sense. And I think the other point I want to make was about space. Something to consider in the cost analysis, maybe beyond this, I don't know, is when you have decentralized systems, especially decentralized tanks, what's the rentable or value of the space that you lose, right? Is your mechanical room that much bigger? Okay, you're shaving off 5 square meters off a 100 square meter unit. Like there's value to that, right? That I don't think that should be ignored in any cost analysis.
As a matter of fact, it's one of our upcoming questions. So I think we move on to the next question, and I'll just let everybody know earlier today, Frank told me that European fire is different than North American fire. So I'm not sure if it has a different accent or what it is, but here we are. Okay, mechanical rooms. Yeah, go ahead, Frank.
Yeah, so building on what we've kind of been talking about, so I believe, can we do more combined mechanical rooms? I guess talk again about the ductwork. Assuming the smaller suites are designed as a secondary suite, is a combined mechanical room cost effective? Would it be changed different if we can get all 4 suites into one mechanical room? What are the requirements for crossing the fire separation? So maybe if Chas can again clarify exactly what he is looking for when we try to do one ERV for multiple units. And then we'll roll right into this question on, if we do a combined mechanical room, how big should that actually be, so that those that actually have to install the equipment in there can do it effectively? And then the final question we can also roll at the same time, is there any concerns with what's called a mechanical closet, mainly for the ADU, where it's probably just an ERV, electrical panel, and that's it? Does that need to be fire rated or anything else, or acoustically rated? Or yeah, comments about combined mechanical rooms, combined mechanical closets. Stuart, you're up again.
I would separate the ERV discussion from the domestic water discussion. Like at this scale, I don't think you're big enough to warrant a central ERV. four to five suites, you're talking like 1,000 CFM, 1,200 CFM. Like that's a $15,000 commercial ERV, either swag on or temp F or something, if you're wanting a high performance unit, versus like a bunch of Vannies or Aldes or whatever. On capital cost alone, you're saving money just using the ERV per suite, let alone all the extra distribution and fire dampers. Fire dampers have to be inspected every year, right? Like just paying for them up front doesn't mean that you're done. Like there's a lot of maintenance cost and stuff down the road with them too. So I don't think this is near big enough to consider a central ERV. You got to be into like 20 plus suites, I think, for that capital cost to tip over. And for the other things to work out. On domestic, it's just a question of like, how are you laid out? Do you have room for a central mechanical space? And if you do, then look at the cost of the equipment, like if it's a Sandon or some of these other new ones that are out there. But keep in mind redundancy too. So if everybody has their own tank, like these things fail. If a compressor goes down, well, now one suite's out of water, but the other one's still have water. But if your Sandon goes down, you're done until the repairs are done. So just cost it out and think about those things.
Isaac, you're next.
I agree with pretty much everything he just said. Yeah, on the ERV side, it makes perfect sense. We're too small for centralized ERV for sure. On a fourplex, makes a lot of sense on a much larger building for centralized ventilation. On the hot water side, we're close to being a centralized hot water here, but in the fourplex probably makes more sense for each suite to have their own individual heat pump hot water tank, right? Then on the actual mechanical system, for looking at that, you can do almost a hybrid system where we do one condenser serving two suites, right? Where we have a fan coil for each suite and all in one mechanical room. I'm doing a project right now where we have a shared mechanical room for upper and lower. One mechanical room has both air handlers, both ERVs, both hot water tanks, all in one room, right? So it's definitely doable, and the rooms are never big enough. Doesn't matter how big you make them.
Yeah, and from the developer's point of view, and Steve, you could maybe speak to this if you're still here. It costs money to build a mechanical room,
Yep.
and so there's always going to be pushback for being really chintzy with the size of the mechanical room.
Yeah, and one way we found is the low profile ducted units, instead of the floor mounted units, save a whole bunch of floor space. So we mount the units up in the ceiling space with bottom access, and then you can fit your ERVs and your hot water tanks underneath of all of that and give yourself a bunch of space and room. And we'll see how this project goes, but it's working out great so far. So yeah.
Great.
Yeah,
Any other comments?
We always stick ERVs above bathrooms and the ceiling, and we stick the fan coils above the entry door. So if you drop the entry, do a low, slim ducted unit, the return ends up right when you walk in the door, and you never sit and hang out there.
Yeah.
And then the duct just shoots out a bit, gets you some distribution, and away you go. So you don't need mechanical. You don't need a mechanical room for the HVAC in the suites. You would just need it for domestic water.
Yeah. We'll throw in a
your
little laundry room as well, in the laundry room sometimes, or
sure, whatever you have, right?
Yeah, there's lots of places you can make room for them. Yeah.
That's
Do you have laundry?
That's what I was going to say. That Stuart just said is, if I can get rid of the mechanical room except for the storage of hot water. Yeah. So yeah, I would say, of course, we want it as large as possible, but we can get it very small if we want. Maybe the equipment should be chosen first, and then you can size the mechanical room appropriately.
Just to add on with the sizing too, I have seen in a lot of situations where there's a stairwell using under the stairs for the hot water tank and things like that.
That's great. That's really good.
Maybe
any other comments about this? Mechanical rooms?
Chas, maybe one other follow-up. Is the requirements for independence slightly different between a secondary suite to a suite versus two different duplexes side by side?
No, you're still gonna have to have independent controls, independent ventilation systems in them. And you think about, I'm just gonna say a big commercial building because it's easier to explain it, like the old, I'll say hallway pressurization, and then you had your transfer into the room. Okay, that's feeding multiple suites, right? But they all had the exhaust going out, so it never went back to building system. Now HRVs are technically, you are keeping everything separate, but like even that, like if you have a common mechanical room, now everybody in that complex has to have, unless you have a condo board representative or something, everybody has to have access to that room. Like now your maintenance, you actually have to have a maintenance schedule, because now the filters have to be changed by somebody, the maintenance on everything. Where if it's in your own suite, it's your problem to change your filter, or if it breaks down, it's your problem to change that fan out. And you don't have, well, one is access, so it has to be on the exterior of a building, or to the exterior, because normally the door is going to have to be going to the outside now, because you don't want to go through someone's suite and give them 24-hour notice to get into their suite just to change the filters out, right? So like on, like these guys are saying, on a little one, it almost doesn't make sense to do that, to have a central system. And then like smoke dampers, fire dampers, or smoke fire dampers, I should say, would put you in the poorhouse probably.
Okay. Next, we have just one more question actually for what we thought for the whole group. Just want to be cognizant of time. And so our last question really is about the, oh, we have two more questions, sorry. So we've already discussed this, right? For the most part. Do we have any other questions in here that we haven't discussed yet? So question 6 is the one I'd like to, or 7. Yes, it is. No, the other one, 6, the other 7. So before everybody has to leave, because we're up to our 2 hours, just about the designs that we shared with you. If after all of this discussion and even your first reactions to those designs, what changes would you make in terms of mechanical systems, whether that's locations of mechanical rooms or the configurations of the plans? And the other question is really about how mechanicals affect the aesthetics or might affect the functionality and the aesthetics of the building. Does anybody have anything to say about those questions?
I guess just think about where you want your penetrations on the outside wall. So yeah, just give some thought to that.
And operable windows, you mean? And how separate, how far they need to be separated, or what?
Yeah, I guess if you're having operable windows or not, but just give some preference as to where you want your, you know, your intakes and outtakes for your HVAC system, so that it doesn't interfere with the outdoor aesthetic of the building. Because it's not, sometimes it's an afterthought and it's like, oh yeah, we need this and this and this, but if we have some time to design that. So yeah, just give some preferences to where you want those kind of hidden.
Awesome. Matt.
Yeah, a couple thoughts from looking at the plans. One is just sort of improving efficiency of hot water is one key for that, is to really group all of the hot water fixtures together if possible in the plans. I know that there's lots of other constraints going on there, but if you can group all those close together and then have it close to where the water heater is, can reduce the need for any sort of hot water recirc, which is one fewer systems to maintain and also one fewer systems to lose energy. And then second would be making sure that ERVs can be located close to the exterior wall and exterior wall, which I'm sure pretty much everyone in the room is also thinking of too.
Yeah, I've seen ERV, HRV ducts that are 25, 30 feet long.
Yeah.
Yeah. Okay, Stuart has a
This
comment.
sort of it dovetails into this, but it also picks up where I think like Chaz was talking about different accessibility issues for central versus decentralized. Like, what's the ownership model of this building? And is it centrally owned and rented?
Yeah, so I
Yeah.
think just to simplify things, Stuart, we just said yes, it's rented. Because we know that it looks different if it's a condo of some sort, or even if it's multifamily and might be owned by several people and sold off in pieces, then then it would look different for sure. So we're thinking about this in terms of affordable housing and then in terms of rental.
Mm-hmm. So if you have one owner and rented areas, then all of those questions go away, and you basically think about maintenance and accessibility from a centralized perspective. Like, it's not the tenant who's dealing with those things, it's the owner. But if you start considering condo strata or, you know, different models, then you might make different decisions. You probably couldn't make this a condo the way it's configured. You'd have to do things differently. So just keep that in mind.
Hey, David, you had a comment?
Yeah, I just wanted to sort of say, while we're talking about the this sort of setup, one thing to consider is how are the utilities actually being billed out to either the renter or the owner? Are we looking at 6 different like electricity meters? Are we looking at one electricity meter and it's just a shared cost? I know in the past we've had issues where you've got one person wants the heat on full blast in the middle of summer. The next person wants cooling in the middle of winter. Who's paying for that electricity cost? Needs to be one of the big considerations.
It is. And so when you're building business model for a rental, it does make sense for the owner to take over all the utilities when they build the building, right? It's very energy efficient because it looks better over, the pro forma looks much better over a shorter period of time. And you're not having to chase people down to pay the utilities. That's also a management cost. So Rod, you had your hand up?
Just a few comments. We are a commercial landlord, and we find the central system much easier to manage because we have a professional go in and, you know, clean everything and service it every 3 months. And we don't have to get into anyone's suite. And then we don't have individuals who don't clean the filters, then the unit fails prematurely. So if you have a rental building, the more you take out of the rental area, the easier it is to manage it. And we also include all the energy in our rent. It's low enough, and in a high performance building, the costs don't vary very much between the units, especially with central systems. You know, all that's left for the individual is basically their appliance and lighting and plug loads. So it makes sense to just include it in the rent and we're done.
Awesome. Okay, any more comments about changes about the design? And I really like the idea that everybody's got the idea that this is just really a generic right now and really high level commentary about the design. And we're not talking about whether it needs 2 sinks in a bathroom or not. So I appreciate that.
Okay. Maybe I might add something, so we have a bit of time for the 2 garage units. Since it still looks like that electric resistance heat, because we're only paying $30 a year for electricity, is still a lower cost option, but that doesn't give us cooling. So how important is cooling? And I guess we saw some options for some of those smaller 1-ton mini splits. Is it worth that upgrade to that from just $100 electric resistance heater to get cooling?
Yes.
It's a good answer. Anybody else?
Yes. Cooling has become the most important feature in our buildings now.
Yep.
And 10 years ago, we didn't even consider putting cooling into them.
Yep. Yeah, things are changing and they'll change a lot in the next 10 years. So yeah, I think
And
the
then
answer
the
is
problem we've had is with the mini splits, you know, the smallest head we can get is about 6,000 to 7,000 BTUs. And, you know, when we have a 300 BTU load in a bedroom, they don't make sense, which is why we went to the central air handler to more balance the loads in the smaller rooms.
So what I'd like to do, and Frank, you could say yay or nay, is to go through the questions that people have posed while we have people here, everybody here. We have 5 minutes before the end of our time. We have a bunch of other questions or a few other questions that are more technical in nature. And if people want to stick around, they sure can. But I'd like to go through the questions in the chat, if that's okay.
Yep.
I'm going to start at the bottom, I think. And So there's a question, it's a question from Chelsea, and Christina has answered it, but the question is about your perspective on the necessity for humidification versus dehumidification in these buildings, assuming that they are more energy efficient, better envelopes. And when is it necessary to consider humidification when it can be omitted from the mechanical, and when it can be omitted from the mechanical design? Any takers on that one? Yes, Stuart.
Like I commented there that generally buildings need humidification in Alberta. When you get in the rental market, we have had occupancy levels get to the point where the opposite is true, where these buildings are getting swamped. Like affordable housing will have new families come in, and there might be five to 10 people in a normal 2-bedroom suite, and the things they're doing in there are not what you might have expected. And suddenly these units are just swamped. And so we've actually swapped out ERVs, like the cores, for HRV cores to help exhaust humidity. All this is to say is that it depends on what you're doing. How airtight is everything? How high are the internal gains? How high is the occupant loading? What are they doing in there? And the answer will vary.
So would we assume that if it's affordable housing and it's pretty airtight, that we probably would use ERV or an HRV?
ERV would be the starting point.
Yep.
For me.
Okay. Any other comments, David? Yes.
One thing that I think needs to be considered is the way homeowners and renters and whatever are changing. Like 10 years ago, everybody went into the office. Now there's so many more people working from home. That occupancy is more 24/7 as opposed to the old getting home from work at 5, 6 o'clock and leaving for work at 7 in the morning. That affects how systems get designed.
True. Okay, Saffron had some really great questions about the building performance, and you can see it in the chat. I'm not going to read it all, but what I do want to say is that we have some future IDPs coming up where we will talk about the fact that we're trying to make generic plans and what that might look like, and how we can ensure that people are actually building the plans, building the buildings the way they should be built, and what that kind of looks like. So that's an upcoming IDP that we'll work on before we dive into these plans. There was a lot of questions about the ducting and the fire dampering for combined systems. Is everybody satisfied that the questions have been answered? Does anybody have any outstanding questions about that? Okay. And I think most other questions have been answered. Does anybody have any outstanding questions that I missed in the chat? If not, we've hit our time mark. We still have some other discussions if anybody wants to hang out. A little bit more technical questions if anybody wants to hang out and talk about those. And you're welcome to leave. We really appreciate you all coming. All of this will be recorded. We're going to ask the presenters to share their presentations. We'll probably give you more information. Because this is being recorded, we can share this whole recording as well. It will all become part of a report, and you'll be mentioned in the report. And as far as the generic plans go, that will also have your names, your company's names in the report. And those of you that didn't do presentations today, and we're not talking about equipment that they're selling, you're in line for a gift certificate draw, which we will contact you about.
Excellent. So yes, for those that need to leave, thank you very much. For those that are sticking around, maybe let's talk a little about the heat pump hot water tanks. There has been some noise concerns. I see there's a few today that there seems to be all of a sudden 2 or 3 new heat pump hot water tanks coming out. Are they all actually the same heat pump in it with a different brand name on it? Are they any better? Are they any worse? How key is it that we are ducting them to do something with the cold dry air that they produce, especially in some of these smaller units, since it appears that there isn't a hard reason in a fourplex for centralized versus decentralized. We're still kind of on the cusp. So if we go to the hybrid route, what are some things we need to worry about?
We design a number of systems with heat pump water heaters. And we actually just make sure that we're passing a decent amount of return air through the mechanical room, just so that the heat pump water heater has a decent amount of air circulation and continue to operate in heat pump mode. I mean, that requires detailing on the drawings to have a transfer grill in the mechanical room door or in the wall or something like that. But that's one way that we use to kind of handle that, because then that cold air is just incorporated into the return air where it's mixed, and then the air handler can add heating and cooling as necessary.
Yeah, I think it's a question of context. Like Stefan said, like for a single family home, yeah, that's how we do it. But you generally have that central air handler furnace type thing that's doing the job there. Do you know, obviously you have to satisfy the manufacturer's requirements for ambient air temperature around the unit. Like if it gets too cold, they don't work effectively and you have to go electric. And at that point, you just spend a lot of money on electric tank. So you need to work within that. The cheap and cheerful answer is, yeah, the closet with a slatted door, and then the air just mixes, but it is loud. So it's a question of who you're trying to satisfy. What's the sort of target tenancy, and what are their expectations? And so we've done the cheap and cheerful. It works. It's loud. Do the tenants like it? I'm sure they don't. It's like a loud fridge. Some of them are louder too. Like it's like something sounds like it's loose, but it's not. But they start to rattle, and like they can be loud for sure. You can obviously, if you have the space, then you can do acoustically lined, elbowed transfers that sound attenuate, and that's great. But you have to have the space for it. And so it depends what you're trying to do.
Isaac?
Yes, we put a lot of these in as well, and typically they're just sitting in the mechanical room, and noise has only been an issue on one install ever that we've done. No one's ever complained about the noise levels on them. But a good portion now in the new homes, clients are asking for cold rooms. So we end up ducting them into a cold room for storage of canned goods or whatever they want to do. And that ends up working really, really well. Then a very small amount get ducted outside. But typically I've never had any issues with the houses getting too cold, the mechanical rooms getting too cold, and noise is almost never an issue. So they're pretty quiet. And they're all about the same. Ream to Stiebel to Renai to all of them, they're all very similar when it comes down to that. Some might be a little bit higher quality, but I don't know. I put almost 5 different brands in now, and if you're standing next to it, you couldn't tell the difference.
Yeah, I think for the single family homes, that solution seems to work easy. I'm just wondering if for these smaller ADUs, are we going to be creating a problem that we don't want? And I guess another question is the price differentiated enough that just a high performance electric hot water tank that's got good insulation, so the standby losses are low. If there's only 1 or 2 people in that small ADU, does that make sense versus the heat pump one that's cooling the space a lot? Go ahead,
Matt.
I think I would tend to say yes to that, Frank, that something like the ADU, if the building is small enough that you can probably get away heating and cooling it without a centralized ducted kind of conventional furnace style system, so you won't have any return air being pulled through a mechanical room. Maybe you're also small enough that you can get away with a high quality electric resistance water heater and then just a really good drain water heat recovery unit. That'd be my leaning, I think.
How big a tank would you put in? 1 bedroom, bachelor suite.
Depends how big the electric resistance coil is in it.
For storage, you'd put a 40-gallon tank in.
Yeah, okay. Are there really good resistance, really well insulated options even? Anybody?
The Ream Marathon is pretty cool.
That's a gas, isn't it?
No, Ream makes gas stuff too, but
Oh, okay.
they're also more money. Like
Yeah, they're really
they're not
expensive.
500 bucks anymore. Like
Yeah.
I would just run the numbers. I mean, so at some point the premium for the heat pump tank is not saved by operational COP. So, and it also depends what's the COP of your space heating system, right? Because these things are largely stealing from the space. The COP of the air source heat pump tank is driven by that. So you can calculate the compound COP, what's the inlet efficiency of the space heat around you, and then the COP of the air source extracting from it. And like, for example, if you have in Edmonton, if you have air source heat pump space heating, the compound COP of that, Ream tank is about 1.6 over the heating season. So you can run the numbers and say, okay, how much are we saving on domestic water? Does it justify the premium for the tank? Does it justify the pain in the ass to deal with the noise and the cool and everything else? And definitely there's a tipping point. At some point it's too small and you just go electric.
Okay. Anybody else about hot water tanks?
I think one thing that was mentioned before was the drain water heat recovery, and the benefits to drain water heat recovery get better with multi-unit. So, well, assuming you can kind of rejig the layout for the hot water things to be right above the drain water heat recovery. But I think that could be a pretty important component, especially if we're looking at trying to reduce the domestic hot water total energy.
With a drain water heat recovery, so for instance, in this ADU, you'd put it underneath, so you'd be in the garage. So that probably isn't the best place for it. So horizontal heat recovery or drain water heat recovery, how many of those are available? Are they viable?
There are some available. They're less efficient for heat recovery. So, I mean, the ideal situation would be multi-unit where you have one main drain pipe and there's one power pipe on that, because then you could get the maximum amount of heat recovery off that. But that means your layout has to be ideal.
Anybody else want to talk about drain water heat recovery?
Yeah, there have been some movements in the market on the large scale stuff. I can find it. We were just talking to somebody who's packaging these things, but like in apartment buildings, they have concocted arrays of the power pipes that we'd usually stick vertically. They stick them horizontally and then they divert from the main sanitary line with a Y and it pulls off a stream, and they're doing some crazy things. And to both Matt and Stefan's point, like, yeah, drain water heat recovery could be way better bang for buck than the difference between electric to heat pump water heating if you can execute it properly. So yeah, don't forget about drain water. I can dig up this stuff and link it.
I think in one of Andrew Peel's slides, he was showing some capture from underneath the tub, so some heat transfer from underneath the tub as well. So there's ways of scavenging drain water heat recovery, I guess, if you want to get creative. I think that's what Stuart's talking about. And I just wonder about people's experience. So that's awesome.
Chelsea had the question about drain water heat recovery, jumping fire walls. Because it's plumbing, as long as it's fire caulked, there should be no concern.
Yeah, plumbing's easy, crossing fire wall.
Plastic or copper, doesn't make a difference.
You just need the right Hilti details.
Excellent. Okay, how about we end with low greenhouse gas emission refrigerants? They've become mandatory in the States. I've been told they're not mandatory in Canada anymore. So I've seen some of the equipment that was shown today is using the new R32 or 134A? Do we see it moving? Is it still going to be slow? How important is it?
Stuart knows.
This has rocked us, this whole thing, this change from 410A to other. We used to be big proponents of VRF. Some of our biggest fully electric projects are VRF, and I'll never do VRF again because of this. I've lost my trust in the industry that they're going to have consistent and non, instantly obsolete products in the decades to come. I look at like the Fort St. John RCMP project, which has like a 75 zone VRF system, fully electric geothermal tied, and it's now tied on a Daikin 410A system. And I'm not sure what they're going to do in 20 years when that stuff reaches end of life. So we've gone wholesale back to hydronic. We, if at all possible, will not use refrigerant distribution in a building ever again. Like maybe 1-to-1 mini splits, fine for like the garage suite, but everything else we're going back to hydronic distribution. So air to water heat pumps, there's a lot of new tech there, which is great. Like the package air to waters outside that can do heating and cooling or geothermal. But yeah, we feel very strongly that this refrigerant landscape is going to continue to change and it'll be nothing but chaos.
That's awesome to know. David.
Just want to sort of say there's no current timescale for if and when Canada's going to adopt the change to the A2Ls. One thing to note that R32 does have a limited life based on the US code requirements, that they're talking of about 5 years before R32, because of the global warming potential, will be also an obsolete gas. There's no timeline yet really to phase out 410s. That's going to be like 410 productions. That's going to be around for a while yet. As for availability, yes, stuff is available. But I know we've got equipment coming in already that's R454 that'll be readily available sort of June, July this year. Yes, it does cost more money. But yeah, stuff's going to be available for service calls for a very long time to come yet.
Isaac.
All right. The first opinion was interesting on the VRV and R32 stuff, because I somewhat agree but totally disagree. I do a lot of VRV, VRF as well. It's a big part of my business. On the transition from 410A to R32 on the Daikin VRV in particular. Don't really have to worry about the whole transition. So the piping is going to be fully backwards compatible. So in 15 years, if you have to replace the equipment, the 410A piping works 100% with the R32 stuff. And the equipment for replacement of indoor units and outdoor units would be available for the next 10 years, at least from Daikin on replacement and all of that stuff. I'm actually excited for the R32 coming into all of this. We're getting reduced refrigerant quantities inside of all the systems and pushing some pretty new stuff. But it's going to be a pain with the transition right now, just as with a lot of the other manufacturers. It's going to be a pain the next year and a half to really get through it, but I'm not going to be stopping VRV, VRF from pushing even harder on that right now, to throw more into commercial and even residential and multifamilies. To do a centralized system is something I've been trying to push for a while. So I think the 32 and the 454 are something that we're going to have to embrace. That's just the way that it's going to have to be. I don't agree with running water everywhere, but that might be because I'm not a plumber. Cost-wise, R32 is way more expensive. It's twice the price for the refrigerant than it is for the 410A. Service calls for the old stuff, still easy to do. Everything will be available. And the cost is more. The manufacturers are charging more for the equipment, whether that's a factor of it being new refrigerant or just a factor of the market basically paying whatever people want to dictate at this point. That's what I got.
Rod, you had some comments as well.
Yeah, we decided to switch from the VRF DX coils and go all hydronic because they're just a little too sensitive. And that's getting all the refrigerants out of our buildings so we can buy these self-contained air to water units and keep them outside. Because the most problems we've had with leakage on any of the refrigerants has been the on-site work versus the units that we actually buy. And I just find that the hydronic is more versatile in the systems that we're looking at.
Great.
Can I comment one more to that? No,
Yes.
so there's some cool VRF systems. Mitsubishi in particular has their it's a hybrid hydronic refrigeration system that kind of brings the best of both worlds. So your refrigeration piping runs from your centralized unit to a branch box essentially, and then distributes hydronic from there to your suites. And you get a little bit more control over it. It's a pretty neat system. That'll probably end up becoming more standard across the line. As much as I like refrigerant, it's hard with the requirements for refrigerant in the spaces on large systems and the refrigerant monitoring and everything that you need. It's going to be more and more challenging all the time.
Mm-hmm.
Yeah, I see all of that as just like escalating sophistication and brand dominance. And like to Rod's point, like hydronic anybody can do. Like, and it depends where you are for sure, but like the difference between hiring a refrig guy to come and fix your system versus a plumber who knows hydronics, like there's a doubling of cost rates right there. And how many people are available, and are you tied to a brand forever? There's just for us, the refrigerant shenanigans here were the tipping point. There all already were these arguments against VRF, but up until that point, we thought, you know, the pros outweighed the cons. But with this refrigerant stuff, we're just like, see ya.
Yeah, maybe I'm biased because I'm a refrigeration mechanic and I operate a refrigeration company.
Yeah, probably right.
Right.
Like, and I get it. I don't want
Yeah.
like, it's a bit alarmist, and obviously it's good stuff. It still works.
Yeah.
This time the piping works out to be backwards compatible, but we didn't know that either 2 years ago.
Yeah.
Like when this stuff got announced, like it's just been chaos.
It's
So,
complete chaos. I can't disagree with that. It's a complete crapshoot.
so when you've put a $5 million VRF system in a building, you can't have chaos like this.
No, I don't disagree with that
That's
at
my
all.
attitude.
Yeah.
Like you can't bring that to the industry. So.
We also had BCIT do a research paper on controls in one of our buildings. And we looked at all sorts of controls. And at the end of the day, all we're doing is monitoring the exhaust air supply. And then adding heater and cooling based on that. And the only way we can get away with that is by having the high performance building envelope. And it substantially, made the mechanical system much simpler. So all the mechanical dampers and everything we put in the building, we just turned them all off. And now we no longer put them in. We just do a good job of balancing the ventilation system in the building up front, and we're done.
It certainly sounds like simpler is better.
Always.
Simpler is a lot better when it breaks and we don't have access to Isaac who can come and fix it for me.
Yeah.
Yes.
For every Isaac, there are 10 not Isaacs.
Yeah, I think that's true. And so, yeah, that's why you have less problems, Isaac, than other people do, for sure.
Yeah, that's true. We do have less problems, but the training involved to maintain, install, and fix the systems is a lot more than a plumber needs to do. 100%. Running plumbing pipe is a lot easier. I can't disagree with that, but yeah, I see where you guys are coming. 100%.
I think that's where it comes down to where is the location of the facility. If you're in the middle of nowhere, sort of deepest, darkest Alberta, trying to get a refrigeration tech out to come and fix your heating system at 3 in the morning on a sort of Friday night, Saturday morning is a lot tougher than it is from somebody in Edmonton or Calgary.
For sure. And the systems are far more expensive upfront capital cost wise to put in as well. They're pretty hard sell sometimes.
And if your engineer doesn't size your DX coil correctly, you have problems forever until you go and buy a new DX coil.
Can't trust the engineer. That's
Not always.
Yeah.
Yeah.
We like We've had VRF systems where the piping was done poorly and the joints failed and contamination entered the system. And again, because of the sophistication of these like VRF condensing units, there's tiny little micro screens in there that get fouled if this happens, and the unit is shot. Not just the compressor, like the whole unit is shot. And so, you know, sequence of events, stupid installation, suddenly like this, you know, $100,000 piece of equipment is shot. So again, this is against VRF.
I want to change your mind. I want to do
Well,
a project.
the technology is awesome, but it's just the execution. We've tried it so many times, and I just
Well, it's hard. That's why it costs so much to put it in, right? That's why plumbers can't install VRFs.
yeah, but they keep trying. And this is Alberta.
do.
Like, if it was a more sophisticated market, it would be easier.
Yeah, good point.
This whole refrigerant change, though, was driven by politicians and not by manufacturers and suppliers to make sure that we had the systems and units in place before they designated we're changing on this timeline. It's the same as the government mandating that everybody's going to be selling fully electric cars by 2030. The systems have to be in place before the government dictates and sets the timelines.
Excellent. Well, I'm sure we could all talk for forever, but as an enjoyable it is, any final thoughts? Thank you all for coming. Lots of great learning, great thoughts.
Really appreciate this, everybody. Thank you so much. And we will have more IDPs going forward. We have at least 2 more just in prep for coming up with these plans that we're planning to come up with. So we'll reach out, and we'd love to have you back.
Any final thoughts?
Thanks. Learned a bunch of stuff today. Great.
Thank you.
Thank you.
Thanks,
Thanks, everyone.
Okay.
Thanks.
Bye.
Cheers.
Thank you.